Hi again, everybody. I'm Joseph again, continuing our saga, how to find a short and some equipment to use. The question was used, as you see, I've been doing videos that I can make 100 videos on finding shorts, every make and model. However, I tried just to give you the basic concept of one, and hopefully you can apply it to all makes or models, because the theory does not really change. So the question is, if I have a parasitic draw from a viewer, if I have a parasitic draw, meaning over time I am pulling current, as I specified, put a current meter between the battery probe, the positive, taking off the positive, and the other side, which is the negative, going to the cable that you just took off. In other words, you're breaking the circuit, putting it in series. We want the battery to be in the state that you found it after it has been drained and draining the current. So if in his case it's 9.8 volts, and it's pulling whatever it's pulling, 8 amps, 9 amps, it's still gonna pull it. That's what we want it, because we can test it when the problem exists. Whenever you have a problem in troubleshooting, you want to confirm the problem first from the customer. You want to simulate the problem as much as you can. That's why you always ask questions from the customer. Was it cold? Was it hot, the car? Did it happen overnight? Did it happen right away? Always these questions you have to ask for diagnostic references. So when we come up to the car in the morning, obviously we can't crank. And obviously we can't even turn the lights on. If you can't even turn on the lights, which are about maybe 12 amps or 15 amps, don't even think about cranking an engine to 200, 300 amps. It'll never happen. So when we do test it, we test the battery at its discharge state, whatever that voltage is, usually 10 volts, whatever it is, and looking at the amp. So when I get a chance, I get a tripod, because as I said, I'm learning myself how to make videos hands-free and all that. I will go and demonstrate it. But the tools that I've been talking about, the meters to use, what I've expressed was, as you can see, I always stress to use this meter, a Fluke, a digital one. Even though this is also digital, but this is auto. So therefore, what I'm saying is, if I want to measure current from the battery while it's being drained, I come in the morning, I can't turn on the lights even. So I say, oh boy, now I want to measure how much current I am pulling in that state. In order to do that, you have to put whatever meter you're using. I want to use the correct meter. If I put it on this, as you can see, that's an AC. This is now the highest that you could go, and with these meters are about 10 amps, because that's how much it's fused. As you can see over here, you have to move the red one, which was originally here to measure volts and ohms. You have to move it to this one. You have to move it to this one. 10 amps. And it's fused at 10 amps maximum. So when I go in the morning to the car, I don't know how much I'm pulling. Maybe I'm pulling more. Maybe I'm pulling 15 amps. I have no idea. But I'm not going to take a chance with a meter that's at 10 amps. Correct? Now, the reason I don't like these is because it doesn't tell you the unit of measurement. You have to understand what this is pointing to. Right now you're on amps DC, signified by this symbol over here. This was AC. The beauty of this one is it tells you what you're on. Even if you're not sure, I put this on volts or whatever, it tells me the unit of measurement right away. So I know I'm on DC, amps, or milliamps. Again, same scenario. Fused at 10 amps. I move this probe which was over here originally, to this one, 2 amps, at fuse at 10 amps. So the most I can use is up to 10 amps. Well, how do I know how much I'm pulling when I go in the morning? Maybe it's 12 and 15 amps, right? So therefore, I like this meter, as I made so many videos about this. Also, the two things that I do is when I crank, I put a voltmeter. I could put it on, like I said, I could put it on minimum, maximum, minimum, to see how much the voltage went down. Or I could put it on hold and then hold it in memory. The other thing is, when I do use this, remember to always, before you use a meter, always connect the two leads together and put it on ohms, and make sure, as you can see, if I have this in the wrong place, it'll make a clicking sound. You have to move this from here and you move it back. Now the clicking sound went away. You have to short these two together, to use the term short together. Now the clicking noise went away. However, this is at 10 amps. So in the morning when I want to crank, I want to see the voltage and I want to see amps. You know how I always stress the unit measurement of amps, how important it is to me, because I want to see what's going on in the circuit, not just voltage drops. So this goes to, and the reason I explain these types of meters, because the average person has these type of meters. These are more expensive tools, much more expensive. An average person on the street is not going to have these type of instruments. So I don't waste too much time on that. I waste my time on this in the videos. Just like some of the, now they have, or the other cars they have, European cars, sometimes they have Torx screws. They figured the average person doesn't have a Torx driver to take out these screws. So this, without demonstrating, I'll make a video, goes around the wire. A clamp meter to measure amps. It goes around the wire. If this would be the wire, you put this around the wire. Because the theory is the wire has a magnetic field around it. From the magnetic field, we can induce a current, and we can figure out, or a voltage, we can figure out how much the current is. And this could go up to, as you see, if I have a good shot, 400 amps at 600 volts DC. Well above what I need to crank an engine to see how much it is. So I have two things. I have a voltmeter to look at the voltage at the most minimum that it'll drop. Let's say it'll drop to 10 volts or 9 volts after it cranks. Then I have the current with another meter to show me how much current I'm pulling. Again, this will go up to 400 amps. A big difference from going up to 10 amps of this one. So again, when I put this over here, this one, I put around the wire. I do not have to disconnect any wires. If you saw the videos that I made, then please subscribe to my channel called Joe Electronics Schematics, which is for students in colleges who are learning electronics, the basics. In order to measure a circuit, you have to break the circuit in series. You have to put the meter in series. Well, sometimes you can't do that, especially when you're only measuring 10 amps with these circuits on with these meters. Therefore, this one you don't have to break any wire. I do not have to cut the wire or whatever, or disconnect the wire. I put it around the wire. I could put it around the battery voltage. I could put it around the negative cable, and it'll give me in volts, not in amps. It'll give me in volts on the meter, and I transform the volts, millivolts, to amps. Again, this will not give me directly. You have to put on the millivolt scale. This is over here. So if I measure 400 millivolts equal to 400 amps, you have to transfer. And you have to transfer the units of measurements. Never get mixed up. So for example, I come in the morning and I measure something 9.8 volts, like that, like the viewer had. I can do the basic things is, as I said, the foundation is, doesn't make a difference what the make or the model is. Chevy, whatever it is, Toyotas, Audis, Hondas, whatever it is, the concept is the same. I was asked how come I don't do videos on every make and model. Well, then I would have to do thousands of videos on every possible system. On the fuel pump of some 20, 30 models, whatever there are, I have to make too many videos. So I teach you the foundation, and basically once you know the foundation, you can apply it to many makes or models. So if I have a problem, have a parasitic draw, and I measure my battery with this, with the meter that I just showed you, putting this on volts, DC. How do I know it's DC? Look, it tells me. That's why I love these meters. So if you're not sure of the range that you put it on, or the unit of measurement, it'll tell you. As opposed to this, it'll just tell you a decimal. That won't tell you DC volts what you're measuring. You have to know yourself. So, again, I pulled out the fuse. I come 9.8 volts. I have a problem. I pull out the fuses. I pulled out all the fuses. It came to this. I'm doing this. As you can see, when I came to this point over here, the current was at 9 amps in the morning. Now I pull out the fuse, went back to 1 amp, went back to normal, and that's what I want. I want to see the problem. I want to mimic the problem. That's what I want to see. So leave the voltage, the battery at 9.8 volts. That means it's being drained. That means I can see the current draw. I can see the problem. So 9.8 volts. I take this out. The current meter tells me 1 amp. Good. So the problem lies here. This was draining it down. Body control module, which is, I made videos about this, about accessories. This talks to the PCM and gives accessories, charge of accessories, restraints, doors, lights, door locks, everything. So I made a video about this. So anyway, I take this out, and sometimes these are not easy to get to. I take it out, and it looks like it was drawing it down. It was pulling down the voltage. Now, this is something that I do that probably people do not do. Once I take this out, I have something called the variable power supply. The variable power supply, I can adjust up to whatever voltage I want. As opposed to a car battery is at 12 volts. It's set at 12 volts. The beauty of the variable power supply is, and many people don't have it, and that's why I don't really make videos about every single thing, you can crank the voltage up from 0 to 5 volts, to 7 volts, to 10 volts, to 12 volts. And at the same time you're reading, there's a display to tell you how much current you are pulling. For example, let's say I start cranking the power supply. I hook it up. I take the positive of the power supply, put it to this point that I'm assuming it pulled me down, and the battery. I take the negative, put it to ground. I find the ground to this module. I crank it up to 10 volts, to 11 volts, to 12 volts, whatever, 10 volts, whatever. I look at the current. The current goes up to about 5, 6, 7, 8, 9 amps. That alone tells me that I'm convinced from this variable power supply that this is draining it. That this is the problem. Because I'm taking something out and I'm putting an external power supply. Instead of a car battery, I'm taking an external power supply with a current meter inside to tell me how much current is being drawn. Remember, when I'm doing that, I'm not even connecting the other things. All I'm doing is taking the module out, and I'm just connecting this to one pin. That's it. That's all the connections are, just to see how it is. So there might be something shorted within, maybe to give you that symptom that you have. Like I said, many people do not do this, but I want to verify, I want to confirm to myself, and I want to reassure myself that these are expensive parts, modules, obviously, make the customer happy. I want to put in external again. What I'm doing is I'm mimicking the car battery. I'm taking a voltage, a power supply of 12 volts, putting in here. I'm reading the amp meter on the power supply, and I'm seeing how much current I'm drawing. If I'm drawing an excessive amount of current, I'm pretty much convinced there's a problem on this. After I took this out of the car. Like I said, I can make so many videos about this, but once you see the make and the model of each one, you can apply the theory of pulling out fuses, or you can make a millivolts. You could put the millivolts on this scale, this one across the fuse, measure millivolts across the fuse. You might measure 100 millivolts, 150 millivolts when the circuit is being drained. But the most, like I said, the most accurate way is always to measure current. That way you know what's going inside the circuits, how much you're pulling. That's the best signaling symbol for me. Anyway, please subscribe to my channel on Automotive Electronics Schematics by Joseph. Like I said, my other channel also for students in electronics, and like I said, mechanics, there are plenty of. They're looking for work. What we need in this trade and this skill are people who know diagnostics, electronics from the ground up. And hopefully these videos will make you understand, and it will convince you to go into the industry as diagnostic technicians, not just mechanics. We don't need those. We need technicians. Thank you for watching. Speak to you later.